क्या?
Good morning, everyone, and welcome to this lecture. Well, this is, I think, lecture number 4, right?
Yes.
Yes. And what we were doing in the last class, tell me, what was the topic that we discussed in the last class?
Temperature scales.
Okay, we had done temperature scales in the last class, and we had seen the relation between various scales. Whatever
Yes.
question, whichever question comes on that part, temperature scale, basically has to be done in same way. What was that thing that what was that formula or concept that we understood in the last class? Can you remind me? How can you solve any problem on the temperature scale? All temperatures are based on the linear nature, though they are not linear. The expansion of liquid or resistance of a wire or pressure, it is not exactly linear, but we consider them as linear and we constructed a temperature scale. What is the thing that you must remember about the temperature scale?
Yes, sir.
What is that? What? Yes, sir. I'm asking what we talked about temperature scale. We went through some formulae, some concept. Do you remember any of those? What was that? Tell me. Don't you recollect what we did?
आपने फॉर्मूला शीट तो नहीं भेजा सर?
If I don't send the notes, that means you are not going to write anything. Is that so?
No, sir. We are writing.
Yes, then tell me what formula did we study yesterday? I told you to note it down. That is my question. My question is not whether you have got the notes or not. You will get the note, don't worry. But the question right now is, what did you study in the last class? What was the formula that you studied in the last class? Even if I give you 1 TB of data, if you don't read it, it's of no use.
For Celsius scale, T
Yes.
minus 0.
Yes. No, just tell me about any scale. What is the general formula? Not for the Celsius scale. For any scale, what is the general formula?
Given temperature minus 0 temperature by upper boundary minus lower boundary.
That is what?
For all scales. General
That is
formula,
what?
sir.
That is a
General form.
that is a constant for all the scales. So
Yes, sir.
that is how you see it. Okay, chalo. I hope that's good enough for you to understand that. Remember, we must be understanding what we are doing in the class. If we don't understand it and if you don't remember it, the class becomes useless. So if I ask you something in this class about the previous class, you must be able to recollect it. If you recollect it, that means there is some that thing is somewhere there in your system. If it has been flushed out of your system, that class was actually wasted. And we, as you can understand, have literally no time in our hands to waste. So let's not waste any time and let us move ahead with the topic for today and maybe tomorrow. Thermal expansion. What do you mean by thermal expansion? You must have heard this term. What do you mean by thermal expansion? Tell me. What is thermal expansion? Or contraction. The expansion is the term that we use.
Temperature increases, the length of the wire will increase.
Length of the wire, nothing else. Why only length of the wire? If I have this sheet, metal sheet, and if I increase the temperature of a metal sheet, then what happens? Length increases only, nothing else.
Volume, area.
Okay. So basically, when you heat up or you increase the temperature of any body, and if there is no change of state taking place, Even if there is a change of state taking place, for that matter, solid is getting converted into liquid. Liquid is getting converted into gas. Whenever any matter is heated, it usually expands. You might find why it is used the term usually, because there might be one or two examples where it actually contracts. Let us not get into that. It usually expands. If it is a one-dimensional body, remember, when I say one-dimensional body, all the bodies that we can imagine in this universe are three-dimensional. They have length, they have breadth, they have height or thickness. But for all practical purposes, if you think about a very long wire, a very long thin wire, now instead of thinking it as a three-dimensional body which has a volume, length, breadth, and height, or length, breadth, and thickness, we can imagine that the length, one of the dimensions, is very large compared to the other two dimensions. So such bodies, such as a very thin wire, even though it is three-dimensional, but the length is very large compared to breadth and the thickness, I can consider such body as one-dimensional body. We understand this?
Yes, sir.
Take the example of a thin sheet that I had just shown you. Now, even though it's a three-dimensional body, but the third dimension, which is its thickness, just hold it. Oh, better I take this one. The third dimension, which is the thickness of this body, is very small. It's very
Negligible.
small. It's very small. So instead of thinking it as a three-dimensional body, we can think it as a two-dimensional body, even though it is three-dimensional. Any other body in the universe, it has got length, it has got breadth,
height,
and it has got thickness or height, whatever you call it. So it becomes a three-dimensional body. Now, if you talk about a one-dimensional body that we have said, length is very large. Length is very large. Other two things are very small. If I heat such a body, even though it increases in volume, I can call it as an increase in the length of that body. If I heat a two-dimensional body, a thin sheet, it expands in area. Generally, any body, when you heat, it expands in volume. That phenomena is known as thermal expansion. Why does this thermal expansion happen? Why do bodies expand? That is the next question, and that might be asked sometimes in your JEE. What is the reason for thermal expansion? So we go into this theory of matter, the atomic theory of matter, and we look at the potential energy graph. Because of this potential energy graph, the body undergoes thermal expansion. When the temperature is increased, the amplitude of vibration and hence the energy of atom increases, and hence the average distance increases.
Distance between atoms also increases, no, sir? Metals.
Average distance between the atom increases. Yes, I've underlined this. What are you saying? Are you saying anything different? Okay. You must have an idea about the curve that we are talking about. Which curve or potential energy curve we are talking about? And I'll show you the curve on the big screen. I've already sent you this sheet. I'll find out whether this sheet has reached you or not. So this is the curve that we are talking about, that is responsible for the what? For the phenomena of thermal expansion. This is the curve, as you can see. I hope you have seen this curve before.
Yes, sir.
Potential energy and distance. At one particular distance, the potential energy is minimum. That is the normal distance between the atoms. When thermal expansion rises, because the well is not symmetrical, so there is no symmetrical about the equilibrium position. As the temperature rises, the energy of the atom increases. The average position when the energy is E2 is not the same when the energy is E1. Do we understand this? The average distance when you increase the temperature increases because of asymmetry in this curve. A body expands usually when it is heated. Am I clear about this point?
Yes, sir.
Okay. You just have to keep this curve in your mind, and that will be the answer for most of the problems that you will see in case of thermal expansion. Why thermal expansion happens? Now, this thermal expansion, if we talk about the three states of matter, thermal expansion is going to be minimum in case of solids. We hardly see any visual expansion in a solid body. For example, if you are boiling milk, which I just did, if you're boiling milk in a container, when you are heating up that milk, you see milk spilling out. You see the change in the volume of the milk. But do you see the change in the volume of the beaker? Yes or no?
Yes.
Do you see it? No, you don't see it. You know it just because you have this information, but you don't actually see the change in the volume of the beaker, because the change in the volume of that solid body is very, very small. That's why you cannot visually see it. But the change in the volume of the liquid is very large, and that is why you can visually see it. Even more than liquids, gases expand more. Why? Because the intermolecular forces that are holding the molecules or the atoms together is minimum in gases and maximum in solids. So thermal expansion is minimum in solids, but maximum in case of gases. We understand this? Anyone must understand this, right? Now we are going to study this thermal expansion. Since we have talked about solids, liquids, and gas, we are going to study this thermal expansion under different heading. And the first heading would be expansion of solids. Expansion of solids. So that is the first heading. I hope every one of you is noting it down. The first one is expansion of solids. So we'll study in terms of three headings, not three, I think two headings. Expansion of gases will be dealing in, we are doing thermodynamics. So expansion of gases, change in the volume of gases. We'll be dealing in PV is equal to nRT, ideal gas equation and all that. And that is also the expansion, the coefficient of expansions for a gas, they are not part of your curriculum. So whatever about gases, we'll be discussing it in coming chapter. Right now, we'll be concentrating on two. What are those two expansions that we'll be concentrating on? Expansion of solids and expansions of liquid. Let us first move on to expansion of solid. Now, this expansion of solids can now be done in three different headings. What are those three different headings? We are going to study the expansion of solids. And we are going to do it in three different headings. What are those three different headings that we are talking about? Anyone? You must have heard about this. Yes or no?
Sir?
Yes. Tell me. Expansion of solids. We'll be doing it in three different headings. What are the three different headings? Or what are the three different types of expansion of solids? I've just discussed it. You must have heard it as well? No?
Expansion of solids, expansion of liquids.
The heading is expansion of solids. In this heading, I cannot have expansion of liquids. Isn't it so?
Aerial expansion, linear expansion, volume expansion.
Yes, the first one would be linear expansion Now, whenever I talk about linear expansion, you must understand that I am talking about a body which, even though it is a three-dimensional body, I am taking it as a one-dimensional body, say, for example, a very thin wire. Then we'll talk about aerial or superficial expansion. Aerial or superficial expansion is the expansion of area
Yes, sir.
of a two-dimensional body. Remember, no body is two-dimensional, every body is three-dimensional. We are just neglecting the third dimension. And then we'll have volume or cubical expansion. I hope all of you have heard these terms.
Okay. Sorry, apparent expansion means?
Let us not go ahead of time and let us stay in the present. That is good. We'll worry about that later on. Okay, so we understand these three terms.
Yes, sir.
Linear, change in length. Aerial, change in
area.
Volume, change in
Volume.
Cubical or volume expansion is the change in volume. You must be knowing about this. Can you tell me what is the formula for linear expansion of solids?
All.
Yes. On what all factor does it depend on? Okay. Go on in that matter. On what all factor does it depend on? For example, I have a solid body. Let us say this is a very thin wire. This thin wire has a length L. The temperature of this wire has been changed by delta theta. I will not use delta T because T is sometimes used for time. So for angles or for temperature, I use delta theta. So I have a wire or a one-dimensional body of length L, and I change the temperature of this body. Let us say I increase the temperature by delta theta. What will happen to this body? Tell me.
Length will increase.
Length will increase. Okay, I agree on this point that length will increase. Let us say that the length increase by this much amount. I hope you can see this amount.
Yes, sir.
This amount is delta L. L standing for length, delta standing for change in length. Now tell me, on what all factors will this delta L stand? Delta L depend on?
Temperature.
No, it does not depend on temperature. Don't use. See, difference between ordinary and extraordinary is only that extra.
Yes, sir.
Difference between confidence and underconfidence and overconfidence, again, very small. Difference between a brilliant idea and a stupid idea is same. Difference between a correct concept and wrong concept is also same. If you just missed a single point, your entire concept, which may be correct, which you understand it correctly, but you are saying it in a very complete sense. You just said change in length depends on the temperature. That is not correct. And what is correct? It depends on
intermolecular forces.
Okay, in a sense, intermolecular forces. And what all these, see, we cannot go very deep into intermolecular forces. On what all factor does this intermolecular force depend on? Then that would be the next question. I cannot write depends on the intermolecular forces here, because we are not talking about those intricacies in the class. See,
Changes depends on an actual length.
Yes, it depends on the initial length. Let me call it as L or L naught. Let me call it as L naught. L naught is not standing for the beginning part. Okay, the change in length depends on the initial length, L naught. If the wire is small, it will expand less. Simple. If the wire is large, it will expand more. Rails, you must have seen this railway track rails. Between two rails, when they are joining, they leave a gap. That is for thermal expansion. Okay, so I understand this, that it depends on the initial length. More the length, more will be the thermal expansion. Anything else it might depend on? Change in length of this one. Yes?
Change in temperature.
Yes, change in temperature is the right term, not temperature. A single word makes a hell lot of a difference. Are we getting my point? It depends on change in temperature.
Not on temperature.
Not temperature. Change
Okay,
in
sir.
temperature. You understand this?
Yes, sir.
Okay. But actually speaking, your answer was not exactly wrong. When the temperature becomes very high, there are in a way it also depends on the temperature, but it is not a part of our curriculum, so that's why we are not discussing it. When the temperature becomes very high, the intermolecular forces also changes, and in a way you can say that it also depends on the temperature, but right now it is not in your course, so you cannot say it. Anything else it might depend on? Someone says intermolecular forces. Yes, it depends on intermolecular forces, but how do I incorporate this? So instead of writing it as intermolecular forces, what I say is it depends on the material of the body. Say, for example, if it is iron, it might expand differently. If it is copper, it might expand differently. Some expand more, some solids expand more, some materials, some metals expand more, some materials, some metals expand less. Why do they expand more or less? Because of the intermolecular forces are different. The densities are different, the atomic structures are different, their strengths are different, everything is different because they are made up of different elements of nature. And that is why we bring this material wala factor here. So this includes also intermolecular forces and whatever is happening inside. Do we understand this?
Yes, sir.
So it depends on these three things. If I put all these things together, if I put all of these things together, I will have a formula for delta L. What is the formula for delta L? The change in length looks like change in length will be equal to
Alpha
alpha. That is a constant which depends
delta
on
T
what?
L naught
Okay, first explain what is alpha, on what alpha depends on. Why is alpha coming?
delta T.
Why is alpha coming? That is my question. My question is not the head, the more part. What is, from where does this alpha
To
come?
remove proportionality.
No, to be very frank, it comes from the material part.
Okay, sir. Coefficient.
See, you must understand that whatever you have studied in your previous class, it might not be wrong, but it not be very correct. You might not have understood it in the same way. Removing the proportional sign, it means it depends on a constant, right? Now that constant depends on something. That something is the material. Getting my point?
Yes.
So what you're saying is correct, but what I'm saying is more correct than what you're saying. So alpha depends on the material. L naught is the length of this initial length, and delta theta is the change in temperature. Do we understand this?
Yes, sir.
From here, I can easily find out the alpha, which is also known as
Delta L by L into 1 by delta T.
what is
Linear
alpha known as?
linear coefficient of expansion.
You have,
Coefficient of linear expansion.
yes, coefficient of linear expansion alpha. If I write this formula in the differential form, and which might be important for you in JEE Advanced, for me JEE is only JEE. For me, JEE means JEE Advanced, because in my time there was no advanced or mains. It was only JEE. It was not JEE, it was IIT-JEE, Indian Institute of Technology Joint Entrance Exam. So when I say JEE, it is JEE Advanced. So when you're talking about JEE, we also have to look at the differential form of this equation for very, very small change in temperature. What is the very, very small change in the length? So I'll write it like this. DL, do you understand DL?
Sir.
DL will be equal to alpha L naught. You can put this in bracket so that it doesn't look bad. D theta. Do we understand this?
Yes, sir.
Okay. Now I can ask you, what is the final length? If I talk about this length,
Delta L plus L naught.
yes. If I talk about this length L will be equal to L naught plus delta L or DL. So if I write it, it will look like this: L naught into 1 plus
alpha
delta theta. Do we understand this?
Yes, sir.
From here, I can find out the value of alpha. And if you look at the value of alpha, this value of alpha will again come as L minus L naught, which is nothing but delta L. Yes or no?
Yes, sir.
divided by L naught into delta theta, or I can write it as dl by d theta into 1 by L. Or I can write dl as d theta multiplied by alpha L naught. So you see everything is coming up together very nicely, yes or no?
Yes, sir.
So if you remember any one of these, you should be able to derive the other ones. I'll give you a minute to note this down. Okay. This is coefficient of linear expansion. I'll give you a minute to note this down. Note it down. Let me know when you are done. Let's move ahead and let us start to think about what happens. What happens when? What happens if instead of a one-dimensional body, I have a two-dimensional body? What will happen then? Now remember, all bodies expand in volume. Here we are just taking them as one dimension and two dimension, as I've already explained. If I have a two-dimensional body, it will expand in area. On what all factors will that change in area or delta A depend on? Instead of delta L, you will have delta A. Instead of delta L, you will have delta A. So on what all factors will this delta A depend on? Change in area.
It is a bit clumsy.
Yes, you can speak, but on what all factors will this delta A, I mean, you have done it before, right? On what all factors will this delta A depend on?
Delta T.
What is delta T? I don't
Change in
understand
temperature.
I've not used T for temperature, so
Delta
better you
theta.
use, yes, it will depend on delta theta. Okay, what else?
Coefficient of aerial expansion.
It will depend on the material of the body. What else? What else? This delta A or change in area will depend on the initial area A naught. It will depend on
Change
the
in temperature.
change in temperature, and it will the material of the body. So I can write this delta E as equal to alpha
A naught.
A naught.
Delta theta.
Put it in here. Delta theta, if I write it in the differential form, dA will be equal to alpha A naught d theta, or dA by d theta is alpha A naught. Do we understand
beta,
it?
sir.
What?
Alpha is per linear expansion.
Oh, yes. So I must not use alpha. I must use a different term.
Beta.
And that different term is beta. The different term is beta, where beta is known as coefficient of aerial
Expansion.
or superficial expansion. Rest of the things are exactly same. On similar lines, you can say when you have a three-dimensional body, change in volume, delta V will be equal to gamma into V naught into delta theta. Do we understand this?
Yes, sir.
Please note it down so that we can move further. Remember, all of them, they are dimensionless or not? They have a dimension. What are the dimension of alpha?
Kelvin inverse.
Kelvin inverse. What is the dimension of beta and gamma?
Kelvin inverse, sir.
So all of them have the same dimension, Kelvin inverse or theta inverse, or whatever you call it, right? Everyone has the same dimension and they are related to each other. They are related to each other. See, you can find the relation. Alpha is this one, beta is this one, and gamma is this one. Final length L dash, or I call it as L, will be equal to L naught into 1 plus alpha delta theta. We all understand this?
Yes, sir.
Have you noted this down?
Just wait.
Yes. Please keep on noting things down. It's a good habit to note things down.
Some problems करवा दो sir.
Please note this down.
Completed sir.
Okay.
Problem करवा दो sir.
Well done. Chalo, and then we move on to the next heading. And the next heading is isotropic solids. Do you know what are isotropic solids? Do you know what are isotropic solids? Anyone? Isotropic solids. Do you know what are isotropic solids? Do you have any idea? No? No one?
No idea sir.
Okay. Isotropic solids are those solids who have the same expansion in all the three dimensions. So whatever they expand in length, similarly they will expand in breadth, and similarly they will expand in their thickness. So they have the same expansions in length, areas, and volumes, or in length, breadth, and thickness. So for all these isotropic solids, we have a relation between alpha, beta, and gamma. Do you know the relation between alpha, beta, and gamma?
Alpha is equals to beta by 2. Alpha
Okay.
equal to gamma by 3.
Okay, so basically you can write beta
Alpha
as
is
2 times alpha
2 alpha.
and
Gamma is
gamma
3
as
alpha. 3
3
alpha.
alpha. Okay. Now you might encounter certain solids which do not have the same expansion coefficient in the 3 dimension. Those solids are known as anisotropic solids. Now remember,
Isotropic.
anisotropic. So they will have different coefficient of expansion in different dimensions. Do we understand this?
Sir.
So in one dimension, they might have alpha 1. In the other dimension, they might have alpha 2. In the third dimension, they might have alpha 3. Now, this is one thing that you might not find in books. So it's important. If a question comes that they have different coefficient of expansion in different dimensions. Alpha 1 in one dimension, alpha 2 in the second dimension, and alpha 3 in the third dimension. In that case, what will be their coefficient of areal expansion? What will be the coefficient of areal expansion? Tell me. Suppose alpha 1 is the coefficient of expansion in length. Alpha 2 is the coefficient of expansion in breadth. What will be their coefficient of areal expansion? Any idea? All the things that we are doing are questions only, beta. Don't worry.
In areal expansion.
Yes.
A into 2 of alpha 1 plus alpha 2.
Yes. Beta will be equal to alpha 1 plus alpha
2.
What about gamma? coefficient of volume expansion. What will be the coefficient of volume expansion? So that will be equal to
3 into alpha 1 plus alpha 2.
alpha 1 plus alpha 2 plus alpha 3. Now, I've seen a question on this in JEE Advanced. No one was able to solve it. The question was like this: in two dimensions, the coefficient of expansion was alpha. In the third dimension, the coefficient of expansion was something else. What is the coefficient of volume expansion? That was the question. 4 marks, JEE. You know how much different 4 marks makes in JEE? It might create a difference of 10,000 ranks. Surprising, no? Okay, note this down and follow what I'm saying. Okay, I have been teaching for 20 years, bacha. I know what to teach. Follow it. Note it down.
E.
Have you noted this down, bacha?
हाँ
Okay.
और प्रॉब्लम तो करवा दो.
Okay, write down the next thing. Do you know what is change in density when temperature is changed?
So once again,
Change in density, variation of density with temperature. Volume changes, right?
yes sir.
Density is mass per volume. So basically, density is inversely proportional to volume. When you change the temperature of a body, does the mass of the body change?
Yes sir.
Mass of the body changes? No, mass does not
Mass
change.
of the body does not change. Volume changes.
Volume changes. So this is one of the most important formulae that you must remember. And this is how the formula or equation looks like. So if I say rho naught is the initial volume and rho is the final volume, how are rho and rho naught related to each other? Again, this problem came in JEE Advanced. We are doing problems only. Don't worry.
Rho naught is initial value.
Yes, beta?
Rho naught is initial value, not density.
Naught is always initial. Naught is always initial. So rho naught is the initial density and rho is the final density. What is the relation between rho naught and rho? This is a question from JEE Advanced. Once you know that relation, you just have to put the values, you will get the answer. As simple as that. Getting my point, beta?
Yes sir. Yes sir.
Yes. All is the JEE Advanced question that we are doing. Try to understand.
Inversely proportional.
Give me the relation. If you don't know the relation, how will you solve the problem, beta? You don't know the relation and you want to solve problems. What will you do? I'll give you first problem and you will solve flat. Isn't it?
Yes sir.
So you must know all the. If you don't have a foundation, how the hell are you going to draw? How the hell you are going to build a building? You don't have any foundation. You have not learned anything in the past 2 years, bacha. That's what I have. That's what I imagine and teach you. Because if I imagine that you know everything, I'll just start with the problems and I can give you in writing the first problem. You will not be able to do anything about that problem. Nothing. And that will be the simplest problem in the universe. I'll have to imagine that, first I'll have to give you some inputs. Then only I can expect an output. You are not a machine. Even a machine cannot be 100% efficient. If I don't put in input, I don't get any output. You understand that?
Yeah.
Yeah. So I'll have to give in some input if I want to expect some output from you. Without giving input, if I expect an output, I would be flawed. So what is the relation between rho naught and rho? If you don't know the relation, you will not be able to do any problem. What is the relation? There are two ways in which you can write this relation. The first way is this way. And since they have written rho dash and I don't use rho dash, so this rho will be equal to rho naught divided by 1 plus gamma into delta theta. Rho is the final density, rho naught is the initial density. Okay, getting my point?
Yes, sir.
Physics is just not about doing problems, because you can't do a problem if you don't understand the theory behind it. If you understand the theory behind it, even 4 problems are good enough. It's not maths that you have to do 400 problems to become good. Only 4 problems and you are good. The topic is over. Not 400. If someone has told you that 400 problems you have to do on your own as practice, not in the class. Okay, now I can write this relation in a different way. How can I write this relation in a different way? This may not be the form in which you see this relation. Then what is the other way in which you write this? You can write this like this. Rho naught will be equal to rho into 1 plus gamma delta theta. This is exactly correct. There is no problem with this. But sometimes you will also find it in this way. Rho will be equal to rho naught into 1 minus gamma delta theta. Is this also correct? These are all problems of JEE Advanced. They might give you this same problem in multiple choice. What is the correct relation? And then you will be stumped. Which of them are correct? First one, second one, third one. If I call this as first one, if I call this as second one, if I call this as third one, which all equations are correct? Tell me. What about equation number 1? Is it correct or not? Equation number 1, it is correct, beta? Anyone?
Sir,
Yes, beta. Equation number 1, is it correct?
I
Equation
don't
number,
have idea about equation 1, sir. Equation 2 is correct.
no idea about equation number 1? Equation 1 is also correct. Remember, it is also correct. It is just written in a different form. Remember, this gamma is a very, very small number. This gamma is very, very small compared to 1. And therefore, using binomial expansion. Do you see a binomial expansion here? Do you see a binomial expansion here? 1 plus gamma raised to gamma into delta theta raised to the power minus 1. And from there, you got this minus sign. Therefore, from equation number 1, you can derive equation number 2. And equation number 1 is derived from equation number 3. So all of these 3 represent the same equation, because this gamma is very, very, very small compared to 1 or whatever you call it. Getting my point, everyone? So all these 3 equations are? All these 3 equations are same. Or for that matter, you can also write it in this fashion. You can call this equation as equation number 4. This equation number 4 is also same. So there are different ways of writing the same equation. Clear? Clear, bacha? Is it clear to everyone? Have you noted this down? Have you noted this down? Shall I move and do your famous problems? I'm also very fond of problems. Okay, I think the volume has gone. Don't worry. We'll get in this together, and we come to the first problem. And now we'll try to understand how much we have understood from the lecture that I have just delivered. Problem number 5. I'll send you this sheet. Okay, not a problem. Mic not working. You are there. I am here. Don't worry. Rest is all supplementary. Okay, so let us solve this problem. Let me just make it bigger. And I'll send you this sheet so you can solve the rest of the problems on your own. And I'm sure if you've understood what I have said in the class, and since you have already done things, you would be able to solve the problem. So what is the problem? The design of a physical instrument requires that there must be a constant difference in length of 10 centimeters between an iron rod and a copper cylinder laid side by side at all temperatures. So at all temperatures, there must be a constant difference of 10 centimeters between the iron rod and the copper cylinder. Alpha of iron is given, alpha of copper is given. Can you find out the lengths of this? Now, if this question comes in JEE Main or JEE Advanced, they may not give you the actual value of this alpha. They might just call it alpha 1, and they might just call the other one as alpha 2. So you don't have to actually calculate the entire thing and give a numerical answer. You can just give an alphabetic answer. By an alphabetic answer, I mean answer in terms of alpha. So they will say that one is alpha 1, the other one is alpha 2, length of first one is L1, length of second is L2, what is the ratio of L1 by L2 or something of that nature. Am I clear with this question, everyone? How do you do it? There must be a constant difference in length. And instead of giving you 10 centimeter, they will just call it as delta L. So the constant difference in length has to be delta L. Coefficient of expansion of the first body is L1. Coefficient of expansion of the second body is L2. This is how they confuse you, and this is how they make a new question. Languages may be different, but the concept still remains the same. If you know, I think I've told you 4 formulas in different ways. One for change in length, one for change in area, one for change in volume, and one for change in density. That is all. Oh, I did not tell you the formula of change in density. I told you the formula of density. From there, I'll make a formula for change in density. First, you do this question, and then I'll give you the formula for change in density. 1 minute, you can do this. Once you're done, please let me know. I'll give you a minute. Shall I do it for you? Okay. Let me call the length of this iron rod as L1 and the length of this copper rod as L2. At any temperature, the length is L1 for the iron rod and L is L2 for the copper rod. Now tell me which one will expand more? Iron expands more or copper expands more? The answer is given in the question only. The coefficient of expansion is 17 into 10 to the power minus something. As you can see, this is very small. The other one is 11. So from here you can understand copper expands more, iron expands less. Right? Okay. So the difference in their length, it will expand more. So let me call it as L2. L2 minus L1 should be a constant. Do we understand this first line? Do we understand this first line? L2 minus L1 must be a constant. Can I have some raised hand that we understand this? Okay. L2 minus L1 is a constant. Now what do? I differentiate both sides. I differentiate both sides. So if I differentiate, I can write it as delta L2 or DL2 minus DL1 is a derivative of a constant. Derivative of a constant is 0. So basically what I get is change in length of L2 must be equal to change in length of L1, or delta L2 must be equal to delta L1. Once I understand this, change in length of L2 and change in length of L1 are similar, I can now simply put the formula of change in length of iron by using the constants for iron, length of iron, alpha for iron, and the change in temperature. Change in temperature is same for both of these bodies. Then on the other side, I have the values for length of copper, alpha for copper, and change in temperature for copper. From there, I will get this fantastic relation that length of iron divided by length of copper will be equal to alpha of copper divided by alpha of iron. Do we understand this? Yes or no? Anyone understands this? Can I have some reason that we understand this? Okay. Now there are a lot more problems here, which we will discuss in the next class. 4 or 5 very good problems. Meanwhile, I will be sending this. I'll be sending this to you. I'll be sending this to you today, and I hope that you get both the sheets. And if you can simply solve the formula, the problems in the sheet, no need to solve any exercise. Just the solve problems. All the problems are given topic wise. So if I do 3 formulas, then I will have formula based on those 3, question based on those 3. Then I'll study another 2, 3 formulas. Then I will have problems on those. Then I will study another 2, 3. Then I'll have problem on those. This way, I am sending you the sheet to the questions in the sheet. We will discuss the question in the sheets in the next class. Don't worry, we'll do a lot of problems. We'll do as many problems as you like, but we'll have to stop somewhere because we don't have that much time. I can teach you thermodynamics for the entire year, and still I will not be done with this because I have so many problems with me. But here's the time that we must understand. We must understand the basic concept, bacha, and we must do selective problems that can get the concept in your head, and that's all that you need. Okay, I hope you understand it better. You have understood understood today's class, and you will be getting this sheet. Take care. Don't worry, I am here. No question will ever come in a JEE which you have not done in the class. I assure you that. Even in the crash course, the small crash course that we did, there were 5, 6 questions exactly same. 1 question, 2 questions were exactly same. Even the same language came in JEE Advanced, and I don't consider main as an exam. I only consider advanced as the exam. So have faith. Faith. Okay. Chalo. We'll meet in the next class tomorrow, and we'll do more problems. Take care and have a nice day.